All right, welcome back, everybody. Today we got lesson 1.6, which is we're going to evaluate and graph piecewise functions, as you can see here. And I'm going to do. I actually have only two examples for you. One of them is going to be just plugging numbers into these functions, and the other one will actually do a graph. And instead of trying to explain what a piecewise function is on this screen, let's go ahead and look at an example of one right now. So here what we see, just, this will kind of, right off the bat, you'll get an idea what's going on. We have a function. There's not an f of x and a g of x. It's just f of x. But when we see what it equals, it's broken into two separate pieces. So you got this little bracket here, and the second example has three pieces. So you can have as many pieces as you want. That's why it's called piecewise functions, because it's in different pieces. So this first problem, we're going to be plugging numbers into this function, this -2, 0, 1, and 5. So we're going to get four different answers to four different questions, basically. Okay. Now, here's really the only thing you got to wrap your head around is this idea that depending on what number it is we're plugging in. So the first one's -2. What this is saying is that use this function x, f of x equals x, if the number that you're going to plug in is less than 1. So for example here, -2 is a number that's less than 1. So it's going to go into this function. Notice the second part of the function, the other piece, is only if x is greater than or equal to 1. So you have to look at the number you're plugging in and decide which of these constraints that it meets, and then use that function to do it. All right, that's enough talk. Let's just do it. So f of -2 equals, and then like I said, since -2 is less than 1, then we plug it into this function. Well, this is the easiest function ever. It's just that it equals that number. F of x equals x, or f of -2 equals -2. So there's an answer right there. 0. 0, remember the first function is you use if x is less than 1. Well, 0 is less than 1, so we're plugging it into this function again. So f of 0, same idea, it equals 0. The next one is 1. Well, 1 is the actual key number in both of these situations, so you got to be careful on this one. This one says x has to be less than 1, period. It has to be less than 1. Well, the number 1 itself is not less than 1. The second function says x would have to be greater than or equal. It's all about this right here, or equal. Well, 1 is equal to 1. So for 1, we use this function. So f of 1 equals 2 times 1, which equals 2. And then finally, f of 5 equals, and once again, you got 5 here. X has to be greater than or equal to 1. Well, 5 is clearly bigger than 1. So we're going to, once again, going into this function. So that's 2 times 5, which equals 10. And we're done. This is the easier one. I don't think it's too big a deal. Once again, you're just looking at the value that they're asking you to plug in and making sure you know which category it fits in, and then whichever one it is, then you use that function for it. All right, here comes the tricky part. So the first one, we're just plugging numbers in and getting answers, and now we're going to think of it a little more generically. We're going to actually graph a piecewise function, and you can see this time I've got 3 pieces instead of 2, and the directions are to graph. There's no numbers to plug in. It's all just about, generically speaking. So what it is we're going to graph this function, but only if the x values we're plugging in are less than -1. Then we're going to make it this function instead if it's from here to here, from -1 to 3, and then we'll make it be this function if x is greater than or equal to 3. So the simplest way to do that is just to make some tables. So we're going to start with, we'll do x minus 2, the first one, and we'll make a little table of x and y's and start plugging numbers in. But we can only plug in when x, we can only put x values here that are less than -1. Now I'm always, when I'm doing the graphs, I'm always going to put in the key value. Even though I'm not really allowed, this is a little bit, maybe seems a little shady. It says it has to be less than -1, but I'm actually going to put it in anyway. I still need to see what's going on at that's a key value on this graph. So we're always going to plug in the endpoints, the key numbers here, into our functions. And then any number less than -1 is just fine. So we'll go ahead and go with -2, and we can keep going. We'll go -3 just for good measure. Okay. And so we plug those numbers in. So -1 minus 2 is -3. -2 minus 2 is -4, and -3 minus 2 is -5. So now it's time, let's start graphing. We're going to have a little graph going over here. And we got 2 more pieces to do, but let's go ahead and we'll make the points like we just did, and then we'll come over here and graph. Then we'll make some more points for this one, and then we'll graph, and then we'll make some points for this one and graph. So -1, -3 is the first point. There's -1 and then down 3, be right here. And then, we could start right there. Let me actually graph the rest of them. -2, -4, which would be here, and -3, -5, right here. And we'd have a graph going this direction like this. We could keep going, right? We could keep putting, I could put -4, -5, -6, because all the constraint is that the value we plug in for x has to be less than -1. Well, there's lots of numbers less than -1. Therefore, as x goes to the left, it's going to go forever. Now, let's talk about this. Notice I didn't put a regular point here. I put an open circle. That's because I wasn't really allowed to plug -1 in there. Remember, x has to be less than -1. There's no equal sign underneath it. So I'm not really allowed to plug this in, but I still totally need to, because -1 is an important part of this thing. It's the key stopping point for this part of the function. So the way we get around it, since I'm not really allowed to plug a -1 in, I put this little open circle here to say, yeah, I know I can't really plug -1, so it's open, it's not really there, but everything after it is. That's how we handle that kind of situation, where it doesn't have the equal sign, but we still need to plot that point like I did. All right, so for the second piece, right here, I'm going to make another table. Here's the table, I'll label it X. And this time we're going to plug in numbers between -1 and 3. So I'm going to go -1, 0, 1, 2, and 3. I'll just do all the nice ones. And since this function, let's see here, since this function is just x, then all the x values, when you plug them in, you just spit out the same y values, because y equals x, basically. So this is -1, 0, 1, 2, 3. We're going to plot those points from, so it'll be -1, -1, and this time you'll notice I'm going to include that point, -1, -1, because x has to be greater than or equal to -1, and so we're fine. We can include that value. And then we have 0, 0, 1, 1, 2, 2, and then when we get to 3, it's another special moment here because it's supposed to end at 3. x has to be less than 3, not equal to 3. So 3 was not really even a number we were allowed to plug in here, but we still need to because it's a key ending point. But what we do is we just put that open circle again. And then we create this right here. All right, and then the last piece is the function x plus 1. So we make a table for that. And the x values that we're plugging in this one have to be greater than or equal to 3. So we start back up at 3 again. Maybe we go 4. If we feel like it, we can throw a 5, a 6, a 7, 8, 9, 10. As long as it's greater than 3, we're greater than or equal to 3, we're fine. We're plugging it into this function, which means whatever number you get for x, you add 1. So x plus 1. So this is going to be 4. This is going to be a 5, 6, etc. So the point 3, 4 would be up here. Notice I'm filling it in because 3 is included in the domain. I'm going to use a little fancier word there. 3 is in the domain for this piece of the function. We're allowed to plug it in there. And then 4, 5 would be here. And if we want, we can go 5, 6. We're just kind of overkilling it now because we know this graph looks like this. We can keep going forever with numbers greater than or equal to 3. So I think this will get you started pretty well. It's just 2 examples today, but we'll go from there. I'll jump in if I need to, but there's, basically there's 2 things going on. One is piecewise, where you're just plugging the numbers into the function, and then the trickier part for a lot of people is the graphing of the piecewise functions. If you have to watch this part of the video again, that might be helpful to you, but let's start here. So I hope this helps. Work hard, be nice. See you soon.